Welcome to this video on adding Poisson distributions for statistics 2, S2. Now, if we have two Poisson variables, let's say x and y, then what we can say is that let's call x lambda 1 and let's call y lambda 2. And what we can say is that if we think of adding our two distributions, then that is the same as the Poisson distribution where our two lambdas are added together. Now, for this, these two would need to be independent, x and y, and they would need to occur in the same interval of time and space. So, if you were looking at these as rates for over a 5-minute period, then it would need to be both of them over a 5-minute period for you to be able to put them together. And where this might be useful is if adding these two values will give you a new value that then appears in your tables. So within a question, sometimes you can put these together to get a value, and then you can use your tables to look it up. But let's jump into a few examples to show you what I mean. So here we have x and y are independent random variables. X's value of lambda is 3.2 and y's is 2.8. So if we look at adding those together, the distribution of x plus y is going to be that 3.2 plus 2.8, isn't it? Or my x plus y is going to be, well, lambda is 6. And that, of course, makes this a very easy question to do. So the probability of x plus y equals 7. So we're just looking at Poisson of 6, so e to the minus 6 times 6 to the power 7 over 7 factorial. And this is 0.138 to 3 significant figures there. Part B. So part B, now we're looking at x plus y is less than or equal to 7. So this would be now using our tables. And we can see right here, so 7, so 0.7440. That's just 744. Part B, we're looking at the probability that x plus y is greater than 4. Now remember, we want to change this into an equals, so x plus y is greater than or equal to 5, which is 1 minus x plus y is less than or equal to 4. So this is 1 minus, and then going back to my table, we're just looking at 4 here. So 0.2851, and then in my calculator, 1 minus that will give me 7149, so 0.7149, or 0.715 to 3 significant figures. So you can see the question is not very difficult. It's just realizing when you've got two distributions, as long as they're in the same time space and they are independent, you can put them together. And usually what that means is that you're able to use a set of tables and make your life a little bit easier. Now here we've got another straightforward question. It's worded, but there's nothing difficult about it. Okay, we can see the word rate here. So we know we are dealing with a Poisson distribution. And you can see for part A, on a given day, find the probability that 2 cars are ordered by company A. So for the first one, if we call X for our company A, and that's going to be 1.25. So think of it like this. Let's go X, 1.25, and Y will be 0.75 there. Now for part A, 2 cars are ordered, so that's the probability when X equals 2. And for that, I like to use the formula. So e to the minus 1.25 times 1.25 to the power 2 over 2 factorial. And that is 0.2238 or 2243 significant figures there. Don't forget you can also use your Casio 991 or 570 if you have the Class Whiz version of those for the distributions. Now we're on to part B, and part B says, on a given day, find the probability that the total number of cars ordered by both companies is 2. This is where we get to put our distributions together. So for B now, we are looking at essentially our x plus y is going to be 1.25 plus 0.75, so it's going to be 2. And we look at the probability that x plus y equals 2. So it's e to the minus 2 times 2 power 2 over 2 factorial. And this is 0.27067, so 0.271 to 3 significant figures there. Again, quite a straightforward question as long as you remember to add your distributions together. And don't forget, like, these are both per day. If one of them was per day and one was per week, we'd have to convert them so that they both had the same time period. Now, for part C, we are again looking at both companies, but we've switched to a 5-day period. So if you remember, when we added these together, we got 2. That was per day, so we need to multiply by 5 to get the 5-day rate. So we get x plus y, so it's not almost an equals there, is Poisson, and it's going to be 10, isn't it? 2 multiplied by 5 for the 5 days. And we're looking at the probability that x plus y is less than 10. So as always, make this equals first. So it's going to make it less than or equal to 9, and 10 shows up in my tables. So here we have the tables. We want 9 less than or equal to 9. So we've got 0.4579 or 0.458 to 3 significant figures there. Now, I don't think any of this is really that challenging, but what I will do is give you a few questions to have a go at yourself now, and as always, I'll go through them towards the end of the video. First question here is quite straightforward, so I will speed this one up for you. So here we can see we have 2 coffee machines, A and B. A breaks down at a rate of 0.1 times per week, and B is 0.05 times per week. Find the probability that in a 12-week period. Okay, so that's obviously what's important here. Machine A breaks down at least once. So we've got the 0.1 rate for A times by 12, and that gives me 1.2. So we're looking at, for A, I'm going to call this A, and the Poisson is going to be 1.2, and we want at least once. So the probability that A breaks down at least once means it's greater than or equal to 1. So that would be 1 minus the probability where A is equal to 0. And that one I can just do with my formula. So e to the minus 1.2 times 1.2 to the power 0 over 0 factorial. So it's just e to the minus 1.2. And this gives me 0.6988 or 0.699 to 3 significant figures. And that, of course, there is part A. Now, part B, that each machine breaks down at least once. Now, this isn't a total, because it's each machine, so we need to think of them separately. So let's look at machine B, so 0.05 times by 12, that's 0.6. So if we're looking at B, it's got a distribution of Poisson and lambda is 0.6, so that parameter is 0.6. And we're looking at the same thing here at least once, aren't we? So we're looking at the probability where B is greater than or equal to 1, and that's 1 minus the probability when B equals 0, so 1 minus E to the minus 0.6 times 0.6 to the power 0 over 0 factorial. And that gives me 0.451188 and so on, which is 0.451 to 3 significant figures. Now here comes the final part of B, because it is each machine. So we want the probability of this happening and the probability that this one happens. So we're looking at the probability where A is greater than or equal to 1 and where B is greater than or equal to 1. So that's my 0.699 times by 0.451. Now, of course, you need to use the full values of these. If you don't, you'll obviously have a rounding error. And that gives me, 0.31529, and it goes up 30 and so on. So we get 0.3153 if you did it to 4 decimal places, or as we've done a number of times, 0.315 to 3 significant figures. So, like I've said to you before, a lot of the time in the exam, like the front of the exam does say 3 significant figures for non-exact answers, and most of the time, or the majority of the time, I remember seeing it in the mark schemes, it will often say answer rounding to, and it'll give you the 3 significant figures answer that your answer should round to the same as that one. Now, part C is a total of 3 breakdowns. So the total means we put in both machines together, so it's as a single distribution. So we have our A plus B, and this is going to be distributed with a parameter or value of lambda of 1.8. I added my 1.2 and my 0.6 there. Total of 3, so the probability where A plus B equals 3. So that's e to the minus 1.8 times 1.8 to the power 3 over 3 factorial. And then let's just go into my calculator. And here we have 0.16067 and so on. So the 3 significant figures, we have 0.161 there. So here we have 3 floors of a building, photocopy on each floor, and here's our rate. So you can see, rate, rate there. And you can see that it's 0.4, 0.2, and 0.8, and everything is per week. So they're over the same time, so we don't need to worry about anything there. Now for part A, we're looking at each photocopier breaking down exactly once. So we've got a first floor, a second floor, and a third floor. So let's call them kind of the ground floor, A. The first floor can be our B, and the second floor is going to be our C for our distributions. So essentially, I'm looking at A is Poisson, and this is 0.4. B is obviously still Poisson, and it's 0.2. And C is my Poisson with 0.8. So I want when the probability when A equals 1 and the probability when B equals 1 and the probability when C equals 1. Remember that and in our probability is generally going to be our multiplication. Yeah, so this and this and this, that's what we're looking at. So this first one is going to be e to the minus 0.4 times 0.4 to the power 1 over 1 factorial. And that's going to be multiplied by e to the minus 0.2 times 0.2 to the power 1 over 1 factorial. And e to the minus 0.8 times 0.8 to the power 1 over 1 factorial. Obviously the 1 factorial is just 1, I could have left that out, and 0.8 to the power 1 or 0.2 to the power 1, that doesn't change that, so I could have just left it as, the e to the minus 0.4 times 0.4, but I've put the full thing in to hopefully make it easier to follow. Now, let's put in some values for these, so we get for the first one 0.26813, and we've got 0.16375 and 0.35946. That then gives me a final answer of 0.0158. This is to 4 decimal places or 3 significant figures here. If you are going to obviously use the full values, that's what I would always say. But if you, for some reason, didn't, or you forgot about it, always make sure that whatever you're rounding off to in the question is at least one more decimal place or one more significant figure compared to what you want to have at the end. Okay, you can see here that's 5 decimal places. At the end, we've got 4 decimal places. This should always be one less than this, and then we shouldn't have a problem with rounding errors. Now, part B says at least one photocopier breaks down. So at least one means we are putting them together. So we've got A plus B plus C. And that's going to be 1.4 there, adding up my 0.8, 0.2, and 0.4. Now we want at least one, so let's put B in there. Probability that A plus B plus C is greater than or equal to 1. So this is 1 minus the probability that A plus B plus C is less than or equal to 1, which actually is equal to 0, isn't it? Should say, not less than or equal to 1, less than 1. So this is 1 minus, now we've got e to the power minus 1.4. We actually got there 1.4 to the power 0, which is just 1. 0 factorial is just 1. And this gives me 0.7534 and so on, or 0.753 to 3 significant figures there. Now, part C says there will be a total of 2 breakdowns. So we want the probability of A plus B plus C equaling 2 there. Because we only want 2 breakdowns across the 3 photocopiers. So this is just going to be e to the minus 1.4 times 1.4 squared over 2 factorial. And then it's just a matter of going to my calculator. And we get 0.241665, so on. So 0.242 to 3 significant figures. And there we have it. So hopefully you didn't find that too difficult. I do think these are still quite straightforward. You know, first part of S2. I don't think S2 is any more difficult than S1. If anything, maybe slightly easier. But yeah, here's adding Poisson distributions. Now what we have next video is finding the mean and variance. So just like we did with binomial distributions, you know, the next step then is to be able to find the mean and variance of a Poisson distribution. If you want to be reminded when that video becomes live, don't forget to hit that bell icon and then it will pop up in your notifications.